Good afternoon, students, and welcome to ELE2314 Laboratory number 4, named or titled the Single-Phase Transformer. Okay. Alright. So the objective of this experiment is to study the voltage and current ratios of the transformer and to learn about transformer exciting currents, voltmeter or volt ampere, capacity, and short circuit currents. Okay, we might not tackle all the objectives, but we will try to do it. Okay, so transformers are probably the most universal use, okay, pieces of equipment in the electrical industry. So they range in sizes from miniature, from smallest to the biggest, and also it weighs a tons. No, some are big and huge. No. And it's used in central power distributing stations. However, all transformers have the same basic properties. No? Remember, all transformers have the same basic properties, which are about to, for us to examine today. All right. So let's get through it. No? And most transformers has a primary power and a secondary power, or a primary windings and a secondary windings, and also a primary volt amperes and a secondary volt amperes, and a primary vars and secondary vars. Okay? Alright, so we will try to investigate how this primary and secondary works in the transformer. Alright, but before that, now let us go to the procedure. Okay? So first procedure, or step 1, as you can see in the manual, there's a step 1 there. So examine the construction of the single-phase transformer, paying particular attention to the transformer, connection terminals, and the wiring. Okay, so in our step 1, it says that the transformer core is made up with thin steels, okay, or laminations of steel. All right, and note that the transformer windings are brought out to terminals, okay, mounted on the transformer coil. Now the transformer we're going to use today is this one. It names a single-phase transformer or transformer, Laboratory Series A3412A. All right. So as you can see, there are some windings, at the faceplate of our module. Okay. So note that these windings are the wired and then wired to the connection to the terminals mounted on the face of the module. So look at this. We have some points here where we can connect the wire when we want to read or get the primary and secondary windings. Okay? So, number 2 step, okay, identify the 3 separate transformer windings marked on the module face. Okay, so what are those? What are those separate 3 separate transformer windings marked on the module? Okay, all right. So list the rated voltage for each of the 3 windings. Let's say winding number 1, or point 1, terminals 1 to 2. So what are the windings? Okay, so the rated voltage is being indicated. So as you can see here, 1 and 2, it has 240 volts. Okay, 3 and 4, okay, the 3 and 4, okay, get the total, here in 3 and 7 is 208, 152 and 56, but the total of this 3 and 4 is 415, okay, 415, 415. And for the terminals 5 and 6, it is 120 plus 120, it is 240. Okay, that is the rated voltage, that is indicated in the faceplate of the transformer. All right. So next, now letter B. Okay, in letter B, list the rated voltage between following connections terminals. All right. So what are the rated voltage for the following terminals? For 3 and 7, okay, terminals 3 and 7. As you can see the windings here, it is set 208. Okay, 7 and 8, 152. Okay, 8 and 4 is 56. 5 and 9 is 120. 9 and 6 is 120. Right? So kindly note that one. And letter C. Okay, in letter C, list the rated current for each of the following connections. As you can see, you cannot find it here. All right? Cannot find it here in the near to the windings. However, you can find it here below. there's what you call said rating. Okay? In the rating, below the voltage, no, below the 240, 415, and 240 is the current rating. Okay? 0.25, 0.15, and 0.25 ampere. Okay? Meaning, in 1 and 2, the current rating is 0.25. Alright? And in 3, 7, 8, and 4, it's 0.15. Okay? And for 5, 9, and 6, it's 0.25 ampere. Okay? So kindly take note on that and list it, no, write it down in your manual. Alright? Let's move on. Now, in step number 3, using the lowest range of your ohmmeter. Okay? So pick up an ohmmeter or a multimeter. Okay? And kindly put it in the lowest range. Let's say the lowest range of this is 200 ohms. No? The lowest range is 200 ohms. Alright? So measure and record the DC resistance of each winding. Alright? So let's start to measure in each windings. So no need for you to switch on yet. No? No need to switch on the power. No? What we are going to do here, we will just measure the resistance, no, of each winding. Okay? Like for example, no, in terminals 1 and 2, so put this one now to 200. Okay? Right? Put this one into 200 ohms, no, as indicated in the lowest, no, the minimum, no, resistance or range of your multimeter, and then connect to, no, terminals 1 and 2. Okay? Terminals 1 and 2. Let's say terminals 1 and 2. Right. So we have 39 or 38.7 ohms. Okay? For terminals 1 and 2, 38.5. Okay, at least 38.5. Right? So take note on that. Right? Next, I will put this one in 3 and 4, no? Okay? I'm going to put this in 3 and 4. Okay? And record the resistance. So this is 128.6 approximately, no? 128.6. All right. Then 3 and 7. Okay? Connect 3 and 7. All right? So this is 61.8. All right? So 61.8. Then 8 and 4. Okay? So 8 and 4. So connect this one in 8 and 4. So this is 19.1 or 19.0 approximately. Okay? Record it. All right? Then next is 5 and 6. Okay? 5 and 6. All right? So let's see how much. This is 40.0. So 40.0. So 5 and 6. And 9 and 6. Okay? The last one, no? 9 and 6, it's equivalent to 20.9 or 20.8 ohms. Okay? Approximately 20.8 ohms. Alright? Alright. Okay. Alright, so that is step number 3. Okay, let us move on, no? Let us go now to step number 4. Step number 4, no? In your manual, it says, you will now measure the uploaded or the unloaded secondary voltages with 240 volts AC applied to the primary winding. So you're going to connect the circuit now, no? So we're going to connect the circuit now. Now this time, you will be needing a voltmeter, AC voltmeter, an AC ammeter, alright? Of course, no, a transformer, and a power supply. Alright, so what terminal are we going to use, no, in the power supply? Okay, let me see. That is 4 and N. Okay, so connect 4 and N, no? Okay, so I connect 4 and N. Then I will connect it to the AC ammeter, no? Here, no, the plus minus. And now, from plus minus, I will use 0.25 amperes. Okay, 0.25 amperes. Okay, so I'm going to get a one wire, 0.25 amperes, connect it to number 1, no? Number 1. Alright. And number 2, connect your neutral, no? From 4 and neutral, no? Okay? So connect it to number 2. Alright. So this is now your primary winding. Okay? So let us now connect the secondary winding. So what we need, no? We need a voltmeter, no, to connect it. All right. Okay. So 5 and 6. So 5 and 6 connect to a voltmeter. Alright. Okay. And lastly, don't forget to connect the 4 and N. No? 4 and N to a voltmeter. AC voltmeter. Okay. 4 and N. Okay. Alright. So this is the full connection of the circuit, no? That is shown in your manual, no? The figure 1-1. Okay. Now, once you connect, no, the circuit, turn on the power supply and adjust to make it 240 volts. All right. So make sure this selector knob is in 4N, no? 4, 5, 5, 6, 6, 4, 4N, no? Make sure that is in 4N, no? So that we can read it here, not the voltage input. Okay, from on the primary. All right, so let us now switch on. Okay, let us switch on the power supply. So make this one 0 first. Okay, so let us switch on. Okay, switch on also this to get you the value of the voltmeter in the 4 and N terminal. Okay, then let us put this one to 240 volts. Okay. As you can see, as I try to increase the voltage, look at the input is increasing and the output as well is increasing. Okay. However, our current is still the same. So we might have this very small current. Okay. So 240 volts. Okay. Okay, I got 239 to the maximum. Okay, that's it. Leave it like that, no? As you can see, the current is very small, no? Very small. We cannot read it, no? We cannot read it. Okay, since we cannot read it, just put it there, 0.01. Okay, 0.01. All right. So look at here, our output voltage, no? In terminal 1 and 2 is 240. And here as well is 240. No? That is in 5 and 6. Okay? 5 and 6. Alright. So, when you do the 5 and 6, now, do also the 3 and 4. Okay? So, switch it off. Okay? Put this one in 3 and 4. Okay? And switch on again. Alright? Then record your voltage, in 3 and 4. That is around 400, 400, maybe let's say approximately 415, 415. Okay? That is the voltage in 3 and 4. Alright? Then switch it off again. Okay? Alright? Go to terminals 3 and 7. Okay? I'm going to remove this. Put this one in 7. So now you have 3 and 7. Right? So, switch it on. Okay. Now, read the output here. Okay, the output, the 3 and 7 is around approximately 200, 200, let's say 210, somewhere 210, okay? Or 208, approximately 210 or 208, right? Then switch it off again. Go to 7 and 8. Okay, 7 and 8. So put this one in 8, and put this one to 7. Okay, and switch it on. Okay, as you can see in the reading, the reading is I will tell you now. Please listen carefully and record it. In my reading, it's about approximately 150. Okay, approximately 150. Okay. That is in 7 and 8. 150. Alright? Okay? So let us go now to 8 and 4. Okay, switch it off. I'm going to put this one in 8 and 4. Right? Then I'm going to switch it on. Now the reading here, at the output, at 8 and 4, 8 and 4 is about 56 volts. Okay, 56 volts. 8 and 4, 56 volts. Okay, kindly note it down. Okay. Alright, so just take note. I will not show you one by one the readings, because it will take time. Just listen to what I am saying. When I'm trying to record it, I will tell you what voltage and what measurements that I measured. Okay? Just listen and record it. Okay? Alright? Now, let us go now to, we already done 8 and 4, that is 56, 8 and 4 is 56. Now let us go to 5 and 9. So switch off. So let us go to 5 and 9. Okay, I'm going to put this one in 5 and 9 and switch it on. Alright, so how much voltage I have? Around 120 volts, for 5 and 9. Okay, 120 volts, for 5 and 9. Okay, so switch it off. And last but not the least, connect it to 9 and 6. Okay, now in 9 and 6, switch it on. Then take the reading. Okay, I'm gonna say it now. Okay, I'm gonna say it the reading. 9 and 6 is around 120 volts. 120 volts for 9 and 6. Okay, got it? Alright. Okay, once you're done, answer the following question, in step number 5, In step number 5, answer the following question. Do your measured voltages correspond well with the rated voltage values? Okay? Okay, this reading is correspond to the rated voltage values. If say yes, you check yes, okay? And give some explanation. If no, click check no and give your explanation. Okay? Alright. So, the next is still number 5, letter B, question. Could you measure the value of magnetizing or exciting currents? If yes, click yes. If no, click no. Okay? And give some explanation, Alright. Okay. So that is step number 5. Now, let us go to step number 6. So in step number 6, windings 1 to 2 and 5 and 6 each have 120 turns, okay, of wire. Windings 3 to 4 has 2,073 turns. Now, calculate the following turn ratios, okay? So, winding 1 and 2, okay, you have 120 turns. And winding 5 and 6, you have 2,073 turns. Okay? So, what are you going to do? Calculate it, by using the formula, in A and B. Alright? Again, you're going to, in step number 6, in step number 6, you're going to calculate the turns ratio with the following formula for A and B. Got it? Okay, let's move on. Now, switch off the power and let us go now to step number 7. Okay? Step number 7, connect the circuit shown in the figure, 1-2. Notice that the current meter I2 short circuit, I'm reading now in the manual, I'm reading the manual. So connect the circuit shown in figure 1-2. Notice that current meter I2 short circuits winding 5 to 6. Okay? So let us do that, So let's remove this. Okay? Keep all the connection except for the 5 and 6. Okay? What do you do in 5 and 6? 5 and 6, put it in the current, meter. That is plus minus, and 6 will be here, 0.25. Alright. Okay, then make sure that this knob, is in 0. Okay? Okay, so this is the full set connection of step number 7, Step number 7. Remember, this is step number 7. Okay. Alright, so what are we going to do? So turn on the power supply. Okay, I'm gonna turn on the power supply. Alright. Now, while you turn on the power supply, increase the voltage here, no? Increase the voltage and look at the I2. Okay? Look at I2. Make sure when you look at the I2, you will get the short circuit current 0.2 ampere. No? Only that. Nothing more, nothing less. Okay? So, when you switch on, so take a look at this. Make sure you are reading until only for 0.2 ampere. Okay? 0.2 ampere only. Okay? So, I'll show it to you. Alright? 0.2 ampere. Okay, so don't make it increase another 0.1, 0.2. Okay? Don't go beyond 0.2. That's what I'm saying. Okay? Why? Because it might damage the transformer. Alright. So measure and record E1, I1, I2. So where's your E1? This is your E1. No? So your E1 here is about 29 volts. Okay? E1, no? Hear my voice, no? The voltage is about 29 volts. Okay? From here, no? 29 volts, and from here also 29 volts. Now your I1 AC is here, no? It's about 0.2 ampere. Okay? 0.2 ampere only. Okay? For I2 is also 0.2. No? For I2 again, I2 0.2 ampere. Okay? So please listen carefully while I'm giving you the measurement. So return the voltage to 0. Okay? I'm gonna return the voltage to 0 again, no? As indicated in the lab manual, and calculate the current ratio. So how are you going to calculate the current ratio? What you need to do, you have the formula, no? I1 divided by 2. So you have the reading, no? You have the reading I1, you have the reading in I2 also. So then calculate. Okay? So is the current ratio equal to the turn ratio? If yes, click yes. If no, click no. And explain why. Okay? If you have still time, no, to do the experiment, we have this circuit, no, figure 1-4. Okay? So go to figure 1-4. Okay? Okay, the figure 1-4, no? I think we cannot do it here, no? Why? Because in the circuit, it says the current meter should be from 0 to 0.15, no? But our range is only up to 0.25. Okay? So we cannot go below 0.25. Okay, so I think that's it, no? Okay, that's it. So at least you know, no? At least you know now what is where's the primary and where's the secondary, what are the rated voltages, and what will be the voltages, no, in each terminals, no? No, so we measured it, right? In each terminal, we have some voltages. And we also calculate the turns ratio of the voltage, and we also calculate the turns ratio of the current. Okay, that's the most important thing. Alright, so thank you, and good luck to your experiment.